I'm Brittany Henderson.
And I am Wadian Price. And we are your teachers for today's mathematics lesson. Let us begin.
All right, so today we're going to be looking at some problem-solving questions.
Yes.
Right? So our focus is going to be on problem solving, featuring algebra, relations, functions, and graphs. So exciting times, and let's jump in. Problem solving. We need to talk about some strategies that you can utilize in your exams to be better prepared to answer these problem solving questions. All right. So.
All right. So the first one is obvious. You have to read the problem carefully, right? And why is that so important?
Because there are times when there are hints in there that you need to pick up, you need to figure out what type of math you're going to use. Yeah. You need to really understand the question. How are you going to understand it? Read it carefully.
Definitely.
All right.
What is the question and what do we need to solve for? And again, straightforward. Because if you're going to actually solve a question, you need to know what are they really asking me to do. So very crucial.
All right. Assign variables to unknown quantities, for example, x and y. So if you're reading your problem and you have some unknowns, assign some variables to these unknowns so that you can then manipulate it later on when you go to solve the question.
Definitely. And as you said, these are just examples, x and y. So it could be any other variables that we are using.
That is also true.
So again, we can translate the words into algebraic expressions by rewriting the given information in terms of the variables. Yeah. Then step 5.
All right, so step 5, set up a system of equations if needed, right?
Yeah.
All right, so we set up a system of equations. And very important, check your solution. So a lot of the times we're going through our questions and we go really, really fast. But in essence, you made a mistake. How will you know? Check your answer. Don't be so sure. Don't be so quick. Stop and check what it is that you're doing.
Definitely.
Or what you've done.
Right, the final answer.
Finale, and we're over, right?
So you can imagine you did all of this work and then don't write your final answer.
Boy, that would be a shame, wouldn't it? All right, so the finale, always write your answer. All righty. Now we're getting into some exciting times. Algebra.
Yeah.
So let's start off with our first algebra problem-solving question. So here we have Mr. Thomas, and Mr. Thomas builds a fence around his rectangular vegetable garden of 8 squared meters. If the length is twice the breadth, determine the dimensions of Mr. Thomas's vegetable garden.
Yeah.
Now, is this something that we come across a lot of the times, don't it? You
Definitely.
have a garden, maybe you have a farm, you need to fence it, right? These are things that we come across in real life. How is it that we're going to help Mr. Thomas?
Right. So have you read the question carefully?
I think so. And I've identified my key points.
Such as?
Such as, one, he has a rectangular vegetable garden, right? So I know the shape, so that's important. I also know the area, which is 8 squared meters. Right. It also told me that the length is twice the breadth. Right. So those are a few things that I know from reading the question.
Definitely.
Some persons are not like me, and sometimes you have to reread the question. So that's another strategy that we can employ sometimes. Sometimes you read it one time, okay, I go through really fast and I read it once. But sometimes you need to reread the question. And so that is also good. And on the second read, you may want to now go ahead and underline or highlight or circle the key facts in the question.
So right. And there's one strategy that we did not highlight, which is very important, and especially for this particular question. Draw a diagram.
There we go. There we go. All right, so let's see what's going on with Mr. Thomas. So we're helping him out with the dimensions of his farm. And as you rightfully said, let's draw a diagram. So we know that this garden is rectangular in shape. So here we have a rectangle.
Yeah. And what do we know about a rectangle? Right? So we know that what? Opposite sides are equal and parallel. So if I know, for example, the dimension at the top here, I automatically know the one at the bottom.
That is true.
Right.
All right. So in this case, we're going to let L be representative of the length and B represent the breadth. So we're going to go ahead and label our length and breadth.
All right.
Okay.
Nice.
So the question did go on to tell us some more information. We also knew the area of this wonderful garden, right? And we knew that the area of this garden is 8 squared meters. And we know that finding area in math, we normally multiply length times breadth. And when we talk about area, what exactly are we talking about?
But it's really the amount of surface in that particular region. Right now, if we had time, we could just divide it up into small little unit squares, but we don't have time for that. And that is where this formula really comes in handy.
Okay, so awesome. So we're supposed to be very familiar with this by now. One other thing that the question mentioned is the length is twice the breadth. And so we can express L in terms of B.
Right.
So L is equal to 2B.
2B.
So here where we have L as our length, we can simply replace that with 2B.
Oh, and we're seeing some common variables here, B and B. All right, so let us see what is going to happen.
All right. So, again, we know the area, 8 squared meters. We also know the formula for finding the area of the garden, which was length times breadth. And in this case, we replace L with 2B. And so it's just simply 2B multiply B, right? And so we can equate both of them.
So 8 is equal to 2B squared. And how do we get the B squared?
Well, B multiply B would give us B squared.
All right. All right, so what's next?
All right, so now we can attempt to find the value for the variable b, and so we're going to be solving for b. So in this case, we have 8 equals 2b squared. We simply divide both sides by 2. So it's 8 divided by 2, 2b squared divided by 2. What we're left with is 4 is equal to b squared, right? Now I know that he's saying, but what's divide by 2, but I don't see divide by 2 on one side. Sometimes, you know, we just skip out that step on, but that essentially what is happening is on both sides of the equation, we're dividing by 2.
Right.
Now, we're here now where it is 4 is equal to b squared. Now, we don't want the value of b squared. We'd like the value of b. Now, how is it that we're going to go ahead and find the value of b?
Right. So similarly, like to the previous step where we divided both sides by 2, what we'll do here is actually find the square root.
Which is the inverse of squaring.
The inverse of this, right, definitely.
So when we find the inverse of squaring, which is finding the square root, we'll find that we'll have 2 solutions.
Yes.
We'll have positive 2 and a negative 2. So b is equal to either positive 2 or negative 2. Now, we're dealing with the dimensions of a garden. Can we have negative dimensions? A question for you guys at home. Can we have the dimensions be negative? Is that possible?
That's a good question.
Isn't it?
Yeah.
All right. So, please note that the breadth cannot be negative, and so we do not consider that solution. So when we're dealing with measurements, we don't consider the negative values.
Definitely.
So in this case, b, or breadth is simply 2 meters, and the length, which is twice the breadth, is in turn 4 meters. Right?
And that's crucial now, so, because students would normally maybe leave their answer at b equals minus or positive 2, right?
Yes.
But this is the final answer now, because it made mention that what? The length is twice the breadth.
Yes. And so you see that final writing up part is very crucial.
Definitely.
Very crucial. So finally, we've written our answer, and so we know that our question is completely finished.
Now, can we prove that our answer is correct?
Of course we could. So we could go ahead and substitute, couldn't we?
Yeah.
We could substitute. So if we went back to the area of the garden, so this is now where we're checking. So we're at the finale, and now we're going to check. But, you know, we can go ahead and check, and so we can go back. So we had 2b, multiply b.
Right.
So here it is that we're finding the area. And we know that b is actually 2 meters.
Right.
So it's going to be 2 multiply 2 meters multiply 2 meters. And that in turn will give us 8 squared meters.
Definitely.
So I can check, and I already wrote my answer, but I can verify that my answer is indeed correct. All right.
So we have gone through the steps.
We've gone through all the steps of problem solving in this case, because if you even notice, we assigned variables to the unknown quantities that we had, right? So we've gone through all the steps of problem solving, and I hope that you guys at home are taking note of this so that you too can go through the steps of problem solving when you're working your questions. All right, next question. Yay.
Yeah. So in a cafeteria, 3 coffees and 4 donuts cost $1,005. In the same cafeteria, 5 coffees and 7 donuts cost $1,715. How much do you have to pay for 4 coffees and 6 donuts?
Well, one thing about this cafeteria, it's expensive. I don't want to buy no coffee and donuts here.
Yeah, it's all really expensive.
Right. But there are times when actually you're spending this amount of money, I don't realize.
But, so we have read the question.
Yes.
What do we notice about this question? I am seeing 2 different situations.
So in this case, we have systems of equations that may come out from this.
Right.
All right.
Well, because I'm seeing some common variables. Coffee, donut.
Okay.
All right? Okay, nice.
So both the scenarios are looking at coffees and donuts. And you get in the total cost, right? But you realize that the quantities of each item is different. Okay. So we identified a few things there. For you guys at home, you may underline this or circle this important information because it will be useful in creating your equations a little later on. You also need to figure out what the question is really asking you for. So it's asking you, how much do you have to pay for 4 coffees and 6 donuts? Very important.
Very important.
All right. So we can press go, right?
Press go.
All right. So again, we're going to assign some values to our variables. So we're going to our variables to the values. So let X be the price of 1 coffee and let Y be the price of 1 donut. All right.
All right. So there were 3 coffees, 4 donuts, and it cost $1,005. So to write the equation, we just simply have what? 3x plus 4y equals 1,005.
Okay. And we also had
5 coffees and 7 donuts. And the cost is $1,715. So this can now be expressed as 5x plus 7y equals 1,015.
1,715. Yes.
All right. So we have our 2
equations.
Systems of equations.
Yes.
Nice.
All righty.
All right. So we get here by
subtraction. So we did some did some processing with both equations. So we went ahead and subtracted our equations, and we ended up with 2x plus 3y is equal to $710.
Yeah.
So it's what, 2 coffees plus 3 donuts equals $710. All right. So why do we do this?
Right. Well, that is why it is important for us to read the question carefully, because based on what the question is asking, then after you have set up your system of equations, then you will realize that if you subtract, because there are various methods in terms of solving simultaneous equation. We could use a graphical method, we could use elimination, substitution. But based on how this question is structured, we see that there's a relationship between the 2 equations. And if I subtract them, then the answer that I will get, I could easily use that to generate my final response.
Okay. So there you go. So another strategy, I guess, is figuring out which one of the methods that you have, because you have several methods at your disposal and when it comes on to math, figuring out which one is the best fit for a particular equation.
Definitely.
All right. So we subtracted. So to end it off, we're going to now multiply all of our terms by 2. Now, here's why we're multiplying by 2. Remember that the question asked us for the value of 4 coffees and 6 donuts.
Definitely.
So if we look at the equation that we have here, where it says 2x plus 3y is equal to $710, we'll realize that if we wanted to find double that amount, we simply multiply.
Definitely.
So in multiplying now, we get the value of the 4 coffees and the 6 donuts, which works out to be $1,420, right? And this was easy, real fast. Look at that. No sweat. We just go through. But I wonder if I'm correct. Are we going to check it?
We definitely can check,
Okay.
right? And our viewers at home can check as well. So how would we check? We would substitute our value for X, which is for what? 1 coffee, right? And then our value for Y, right? Multiply 4 times the cost for the coffee, 6 times the cost for the donut, and then our answer should be $1,420.
Awesome.
Yeah.
Right? No stress.
No stress.
And we simply are going to again write out our final answer.
Yeah.
So we did not skip that stage, guys. We went ahead and we wrote out our final answer. So in this case, our final response is 4 coffees and 6 donuts cost $1,420. So put on a nice, pretty bow and we're finished.
Nice.
All right. So that's just 2 questions down. I hope you guys are still with us and you're getting the hang of this as we go along.
Yeah.
All right. So next question.
So at a theater, 1,000 tickets were sold, right? Now, adult tickets cost $8.50. Children's ticket cost $4.50. And a total of $7,300 was collected. How many tickets of each kind were sold? So here, what I'm seeing again, this is a similar situation to the first one. Right? I'm seeing some common variables. Children's ticket, adult's ticket. Right? And then I'm seeing some costs involved. So I can use the same strategy that I used before to set up a system of equation.
Yes, indeed.
All right.
All right. So 1,000 tickets were sold. Okay, maybe you think this is Jamaica or is America?
Have to be America.
All right, so let X be the number of adult tickets and Y be the number of children tickets. So again, we've assigned values to the unknown quantities that we have. So again, we can formulate 2 equations out of the given information, and we're going to give you those 2 equations. Or wait. How about this? You quickly write down the 2 equations that you see coming out of this one before we give you our 2 equations. So quickly, guys, formulate your 2 equations that are coming out of this scenario. All right, you think they're formulated already?
I should.
Okay, so the total number of tickets. So we have X plus Y is equal to 1,000. So we know that there's a total of 1,000 tickets. Part 2. The total money collected. So we know that we sold some tickets to both adults and children,
Right.
and that equated to $7,300, I believe. Yes. So the ticket cost. So the adult tickets were $8.50. So that's why we have 8.5x plus the children tickets were $4.50, which is the reason why we have 4.5y.
Okay.
All right.
All right. So for that second equation, so since X is a number of adults tickets, so let us say I have sold 5 adults tickets. I would multiply that 5 times $8.50.
Which is the unit cost.
It is the unit cost.
Yes.
Right? And if I had sold 7 children's ticket, I would have multiplied 7 by $4.50.
Again.
Add my cost, total cost, and then I should get what it is equal to.
Yes.
That's what we are saying.
Yes, that's exactly what we're saying
Definitely.
here. All right, so I hope we're all on the same page.
Yeah.
Okay. So, in equation 2, we'll make the coefficients whole numbers by multiplying both sides by 10.
Yeah.
All right. So it's just for ease of computation that we're doing this. It makes it easier for you to be able to computate when it is that we're dealing with whole numbers. All right. So, all right, we have x is equal to 700 and y is equal to 300, but how did we get there?
How did we get here? All right. So again, we can use any one of the different methods that are there. All right, but we're gonna go to the board. We're gonna go to the whiteboard, and we're going to use one of these strategies to see if our answer is actually correct. All right, so our equations. First equation, x plus y is equal to 1,000.
Yes.
Then it's what? 85x
Plus 45y.
plus 45y is equal to
73,000.
73,000. All right. Now, the method I'm going to choose is substitution. Right? Now, the reason I'm choosing substitution is that I realize that in equation 1, for example, the coefficients there,
Are 1.
both of them are 1.
Yes.
All right, so I can easily use substitution. All right, so from equation 1, I'm using equation 1. Right, so this is equation 1, and this is equation 2. Right, I'm using equation 1. So equation 1 says x plus y is equal to 1,000. So let us say I want to find the value for y. I would just subtract x from both sides. That would leave y is equal to 1,000 minus x. Right, so this now is my value for y. So wherever I see y now in equation 2, I can substitute 1,000 minus x.
Yes.
All right, so let us do our substitution. All right, so in equation 2, we are substituting in equation 2. So it is what? 85x
Plus
plus
45 multiply 1,000
minus x. Because that's the value for y.
Yes.
Right, and all of this is equal to
73,000.
73,000. All right, so all I need to do now is to just use my distributive law here. So 85x plus 45 times 1,000.
45,000.
That's 45,000.
Subtract 45x.
45x equals
73,000.
73,000. All right, so I can do a quick calculation now. So here I'm seeing 85x, and I'm seeing
45x.
45x.
And you're subtracting,
And I'm
so we're grouping like terms.
Grouping like terms right there. So I'm just taking away 45x from 85x. That would leave what?
40x.
Just 40x. All right? And that is equal to, I'm doing a number of steps in one. Because at this level, at grade 11, we should be able to skip some steps. Because remember, we are working against time as well.
True.
So while we are explaining the steps, you should be able to skip some of these steps. All right? So this is a positive 45,000.
Yes.
Right? We're going to subtract 45,000 from both sides. So this 45,000 will be gone. Then I'm going to subtract 45,000 from 73,000. Right? That would leave me with what? 28,000.
Yes.
Right. Right? So I just need to do what now?
Simply divide by our coefficient
both
of
sides
x.
by coefficient.
So it's 40.
So 40, 40.
Yes.
Right?
Yes.
All right, so 40 into 28,000. That would leave
700.
700. Right, so here we are seeing that x is equal to
700.
700.
All right.
All right. And so now, are we finished?
No, because we only have the value of x.
X.
So we need to still find the value of y.
Right.
Right.
All right. So here again, since we have the value of x to be 700, we can always substitute now
To
this
find the value of
in,
y.
in one of the equations. All right. Now, if you realize this is a new equation that we had formed, right? So we could call this equation 3. So an easy equation to substitute in is always equation 3.
Yes, because the coefficient of x and y
Right.
are just 1.
Which is this one, by the way. All right?
Oh,
So here we
increase
have
of three.
now y is equal to
1,000 subtract
subtract x.
700.
So it's 1,000 subtract 700.
So therefore, y is 300.
Y is 300.
Look at that.
All right, so we have just gone through this particular question, right? We showed our answer first, and then we use the substitution method to solve the system of equation. Again, we could have used the elimination method, right? Or any other method of your choice, right? The important thing is that we arrive at our correct response. And again, we can easily check by just substituting our answers back in any one of the two equations, right? So if I substitute x 700 for x in equation 1 and 300 for y, again in equation 1, I'll get 700 plus 300 gives me 1,000. And the same thing, if I had done that in equation 2, then my final answer must be $73,000.
Yes. And so we've checked our answer. And very, very last, final, we have to wrap it up in a nice bow. We've also gone ahead and written the final answer. So here, therefore, the number of adult tickets sold is 700 and the number of children tickets sold is 300. And this is very important and pointed because now we are answering the question that was asked of us. Right?
Definitely.
So you telling me X and Y, yes, I mean, I can go back up the top and see, but me putting it nice and dandy to let you know exactly what X and Y represents and exactly what 700 and 300 represents is important. So do not negate this fact and say, sure, them can go figure it out. All right, so let's look at another question. So going for a long trip, Thomas drove for 2 hours and had lunch. After lunch, he drove for 3 more hours at the speed that is 20 kilometers per hour more than before lunch. The total trip was 460 kilometers. What was his speed after lunch? Wow. No, this is a long one. Maybe for this one, you may need to reread,
Definitely.
right? So you may need to reread this question to get exactly what the question is saying. Because, you know, it said my speed before lunch and my speed after lunch. What is that?
Yeah.
So you reread the question and highlight the important facts.
Right.
All right. So how do you think we can approach this question now?
All right, let us dissect it. So we have read through a number of times. We pick out our important information, right? So we are ready now to put a strategy in place.
Yes. All right. So let's take a look. So we're going to let x be the speed before lunch. All right. So the distance driven before lunch is equal to 2x. All right. After lunch, the speed is 20 kilometers per hour more than before lunch. Now, is that important?
Definitely.
Okay. So, after lunch, the speed is therefore x plus 20.
Right, because before lunch, the speed was just
X.
Right, so if it's 20 kilometers per hour more, then we have to add that 20. If it had said less, then we would have
subtracted.
Right.
Okay. So now the distance after lunch is therefore 3 multiply x plus 20.
Yeah.
All right. So the total distance traveled was 460 kilometers. And hence we have this equation here. So we just put everything together. So it was 2x plus 3 multiply x plus 20 is equal to 460. So at this stage, we can go ahead and solve. All right. So solve the above equation. We'll find the speed before lunch as x is equal to 80 kilometers per hour. And again, as Mr. Price would have done, we would have gone ahead and used the distributive law. We would have then grouped like terms, right? And in this case, it would have been 3x plus 2x, which will give us 5x.
Right.
And we're using the distributive principle, so it would have been 3 multiplied 20, which would have given us 60.
Right.
And then we'd simply just subtract 60 from both sides of my equation, which would leave us with 400. So it would have been 5x is equal to 400. And when we divide 5 into 400, we would have gotten 80 kilometers per hour. And we did all of that without lifting a pen.
Yeah.
Look at that.
Yeah, and that's a good approach to take. Because if we are going to use calculator for everything that we are doing, time is going to run out on us.
Don't. Right? And sometimes you don't even realize how to use a calculator properly. Tapping and you don't know what to do.
Yeah.
So utilize these as the things. The distributive law, okay, I learned that over there. And I learned about grouping like terms over there. But put everything together because math is not one thing over there and one thing over there. Everything comes together to make everything make sense.
So true.
All right. So the speed after lunch is 20 kilometers per hour more than that before lunch, and therefore 80 kilometers per hour plus 20 kilometers per hour would give us 100 kilometers per hour.
Nice.
So we answered that question.
Yeah. What we are seeing as well, the speed after lunch is faster.
Yes.
Right, he got more energy.
Really? Or
After
maybe
lunch.
more to hurry up to go home to sleep. Maybe.
Who knows?
Right?
All right.
So, nice. Volume.
Yeah.
So here we have another question. So I hope you guys are getting the drift of how to do these questions. So here we're looking at volume. So the volume V of a gas varies inversely as the pressure, the temperature is held constant. All right. So volume varies inversely with temperature.
Yeah.
Inversely. What does that mean?
So these are two concepts that we would have heard. So it can vary inversely, or it can vary as well directly. Right? In this case, it varies inversely, means that as one increase,
The other one.
the other one decreases. Right? So as volume increases, for example, the pressure in terms of the temperature decreases. So that is what it means by inversely. If it was directly, as one increases, the other increases as well.
So inversely is like opposite then?
Like opposite.
Okay. So the first part of the question asks us to kindly write an equation relating V and P. So we just talked about the inverse relationship.
Yeah.
How do we now go ahead and write that as an equation?
Yeah.
Oh, really?
Yeah, just that.
Wow. So V is equal to K divided by P. That's it?
Right. Or if persons wanted to write it another way, it could have been written as V is equal to 1 over P, or 1 divided by P times K, or K times 1 divided by P.
To show the inverse
to show
relationship.
that inverse relationship.
Okay. All right, so part 2 of the question says, if V is equal to 12.8 when P is 500, determine the constant of variation. Now, constant of variation, what is that? And how do I identify that from the equation that I wrote?
Right, so from our equation now, we would realize our constant of variation would be that K. Right, so that is what the equation is changed by. Right, whether it is a positive number or a fractional number, then it will determine how the change happens. All right, so when it is asking for the constant of variation, it's just asking us to find the value of P, really.
Okay.
Right, and now we have our value for V, which is 12.8. We have our value for P, which is 500. All we need to do now is to substitute those values in the equation that we have formed and find the value for P.
For K.
For K.
For K.
Which is our constant.
Yes. So we're finding the value of K. All right. So as you can see, we went ahead and made K the subject of our equation. So there are several ways you can do it. Maybe this is easier for you to see, to just go ahead and make K the subject at the beginning. So again, we made K the subject and we simply substituted as Mr. Price would have said. So it's 500 multiplied 12.8, which gave us 6,400. And that would be the value of K. Wow. This is how simply the problem solving things come?
Simple. Right?
I thought they were more
at
difficult.
times the terms just throw us off.
Inverse and constant of variation.
It sounds more like physics.
It does.
Right, so it must be difficult.
But maths and physics.
Maths is physics.
Yeah. Okay. All right. Oh, so the question does not stop there. It then went on to say, calculate the value of V when P is 480. Now I'm seeing a little bit of a trend. One part of the question is related to another part, and this happens a lot on our CSEC paper.
Yeah.
So part A is related to part B, and part C is related to part... It's coming back here.
Coming right back.
Okay.
Right.
So, again, we're starting off with our equation. V is equal to K divided P. And we're going to substitute. So as we would have found in the second equation that we worked through, or the first one that we actually worked out, K is actually 6,400. So we're going to simply substitute in this case K with 6,400, and we're given the value of P, which is 480. So in substituting, we can then go on to find the value of v.
Definitely.
And that is 13.333333333. You ever see a calculator doing that?
Yeah,
What does that
yeah.
mean?
The numbers are just recurring.
Ah,
Right? So
indeed.
there's no need to write out all of these threes. Right?
Good.
You just simply put a symbol there.
So put a little asterisk there to mean that it's
You know,
recurring.
it's recurring.
Okay.
All right.
All right.
Yeah.
So that was another question. Boy, we're going places,
Going
Mr.
places.
Price.
Going places.
Yes, we're on to another one. So the length in centimeters of the sides of a right angled triangle are A subtract 7, and A plus 1. Okay.
So those are just three sides.
Yeah, man.
And it must be three because we're talking about a triangle.
Yes, and they did specify that we're looking at a right angled triangle.
Triangle.
What that mean again?
So seeing that again should turn on a light in my head. Right angle triangle.
Mm-hmm.
What am I seeing? All right, one of the angles should measure 90 degrees.
Should.
All right? I'm seeing if it is a right angle triangle, I must have a hypotenuse. Right? I mean, not know which side is opposite and adjacent. That is not important, no. But there's a hypotenuse, and my hypotenuse must be the longest side on the triangle. Right? So having that information in my head, then I'm looking at the dimensions that are given, the A minus 7, the A plus 1.
So I can now visualize it before I draw it. But then, you know, we're going to get our little ruler out and our pencil, and we're going to actually draw it. So the question also says that we're going to use Pythagoras' theorem to write an equation in terms of A to represent the relationship among the three sides of the triangle. All right, so first let me draw my triangle.
Yeah.
Okay, wonderful. I've drawn my triangle and I've labeled the sides in my triangle.
Question.
Go ahead.
How do I know where to put the different values? I'm seeing three values up there in terms of the length of the sides. A subtract 7, and A plus 1. How do I know where to put, especially the A plus 1?
All right. Well, you mentioned something very important at start. When you mentioned the hypotenuse, I know that the hypotenuse is the longest side in my triangle. So if I have A subtract 7 versus A plus 1 versus A, the longest side has to be A plus 1.
Nice.
You thought you could trick me? You thought you were going to get me this morning.
You're good. You're good.
All right. So there we have it. So we labeled all the sides in our triangle. And now we're going to integrate somebody that everybody knows about. Pythagoras, right?
Yes.
You're supposed to hear his name over and over in your class. All right. So how do we utilize Pythagoras' theorem here?
All right. So what does Pythagoras say? Right, in terms of a right angled triangle.
Oh, Lord. This is going to be a mouthful. So, the sum of the square of the two shorter sides is equal to the square of the longest side in my triangle, which in this case is my hypotenuse.
Definitely.
Okay.
Mouthful.
Oh, Lord. That was a lot. All right. So, let's see. So, there we have it.
Yeah.
So, side square plus side square is equal to hypotenuse square. So this is really what Pythagoras tells us.
Right. And I like how you write the formula in terms of side square plus side square. Apart from writing A square plus B square equals C square.
Tell us what is wrong with that, because I always hearing it. Why?
Right, because the triangle don't have to be labeled ABC.
Exactly.
Right, it can be labeled PQR.
The importance is understanding the
sides and their relationships.
The concept. So exactly.
Right.
So we need to understand the relationships between the sides.
Yeah.
So there you go. Not A squared plus B squared equals C squared. Mark that out.
Mark that out.
Okay. So we can now go ahead and substitute, right?
Definitely.
So before we even do anything, the hypotenuse, the length of the hypotenuse is?
A plus 1.
A plus 1. And we can side square can be any one of the two sides, right? So there you have it. And now we're going to attempt to now simplify our equations.
Yeah.
So we're going to solve the equation for A. All right. So here we have a few important and interesting things. We have A squared plus A subtract 7 all squared is equal to A plus 1 squared.
Yeah.
Those squared things. I'm nervous. So if we did a little bit of an expansion of brackets, right? So expanded our brackets, we would have gotten something that looks like this. a squared plus a squared subtract 14a plus 49 is equal to a squared plus 2a plus 1. Lord. No, at this stage, can we do anything interesting?
Well, I'm seeing some common terms.
Okay.
Right, so I can go ahead and group those common terms.
Okay, so I can group my like terms.
Yeah.
Yay. Grouping them. Magic.
Yeah.
So, so we grouped all of our a squared terms together, and what we're left with is simply a. We also had minus 14a subtract 2a, and so we have 16a.
Right.
Plus 49 subtract 1, because we would have then subtracted 1 from both sides. So we're left with 48, and that is equal to 0. Now, this looks like something I've seen before. What does this look like to you?
It looks like a quadratic equation.
And how do we know that it's a quadratic equation?
Well, I'm seeing that the highest power there is a square.
Indeed.
A square. So the a squared, right, and it goes down. I'm seeing that the powers are going down by 1. So I have a square there, then the power at the a there is just 1, and then in the 48, I'm not seeing an a, right? I could always say that there's an a there, but it is raised to a 0 power, which is just 1.
Yes.
Right? So it is in the form of a quadratic equation.
Okay, so this is also an interesting one that we're introducing now. Yeah. Can we solve this quadratic equation? Yeah. Do you guys at home remember how to solve quadratic equations? This is a very important tool, especially on your exam.
Yeah.
Right. So, how we get this?
All right, so again, there are various methods you could use. Obviously, this one is that we just factorize. I'm seeing where this seems like the AC method.
Okay, so we did some factorization.
Here.
Okay.
All right, but if persons wanted to use, let us say, the formula, right, they could go ahead and use that. It depends on what you're more comfortable with.
So here we're not stipulating which method you should use. Again, we're saying to you that you have an arsenal. You know all of these things. Dip into your tool chest and take out what works best for you for the question. Yeah. All right. So this is saying a subtract 4 multiply a subtract 12 is equal to 0. And we know that in this case, it simply means that a is either equal to 4 or a is equal to 12. Sorry? So a is equal to 4 or a is equal to 12.
So all we did was to equate both of these terms to 0. So a minus 4 equals 0 or a minus 12 equals 0. Right? And the reason for that, if you're multiplying two terms and you get an answer of 0, it means that one of the terms must be 0.
Exactly.
Right? 4 times 0 is 0. 100 times 0 is going to give a 0. So one of them is equal to 0. I'm not sure which one. So I equate both terms to 0 and then solve.
All right. So now it says hence. So since we've done this, hence state the length of the 3 sides of our triangle. And all we're simply doing now is we're going to substitute. Right? So we're just substituting the value of a for all 3 sides.
Yes.
Right. So I'm going to ask you guys now at home to go ahead and substitute.
So this last part asks us to, it says hence, state the length of the 3 sides of the triangle, hence.
So hence, meaning that I'm going to use something that I had from before.
Definitely.
Right. So it's all connected.
Yeah.
All right. So we knew that from before we had a, the value of a being either 4 or 12. Right? So we're going to get, so if we substituted what? In this case, we substituted a, so the value of a here is 12. And so one side would have been 5 centimeters, the hypotenuse, 13 centimeters, and another side, 12 centimeters.
Right. And I'm hearing someone asking the question.
Why not 4?
Why not 4? We have gotten 2 values, a equals 4 and a equals 12. How did we know that we should use 12 and not 4?
Well, here it is now that we're going to look at our arsenal. Now, we know about a few things about numbers and length and, these dimensions. Can we have a negative dimension? Can we?
And that's a concept that we looked at
before. Look at that.
Right.
So if it is that we substituted A for 4, we would have for one, the length of one side being -3 centimeters. Now, is that possible? Ask yourselves that
But
question.
why it's not possible though? We know that we cannot have a dimension or a length being negative, but why not?
You tell me why not?
Right? Because when you look at the number line, negative means what? It's less than 0. Now think about a dimension that is less than 0. Does that exist?
Could I see it?
I can't see it.
No.
I
So
can't
then
see
we would
it.
have a problem.
We'll have a problem.
Yes, so it could not
It
be
could not.
less than 0.
No, it could never happen.
Okay.
No.
So there you go, guys. So that is how we knew which one to substitute to find the length of the sides.
Right.
Now, this may be a trick question for them on the paper, right? So I hope you're really taking note because something like this may very well come back and you have to say to yourself, but wait, how I get that again? Remember what we did here this morning.
Definitely.
All right.
Now, remember that last step in the strategies that we highlighted, or the second to last step, we have to check our answer.
Indeed.
Now, does this represent a right angle triangle?
Well, as far as I know, yes. Doesn't it?
So I'm
yes.
seeing that the hypotenuse
is the longest
side, and that remains.
Yes.
So that should give me an indication that I am on the right track.
Yes, indeed. So you mean that if I did my working out and the hypotenuse was the shortest side in comparison to everything else, something wrong?
You're going to lose some marks.
What do you
because
mean?
It asked me to label. If I'm going to label my triangle, then the dimensions must be accurate. The longest side could never be 5 centimeters, while another side is 13.
Indeed, indeed. And also, the hypotenuse is directly opposite my right angle. That is also something that is important to note. All right. So, guys, you know, we're going on and we're going on strong. We're going on well. We're writing down our final answer. All right, here's another one. So here's another question. A strip of wire of length 32 centimeters is cut into 2 pieces. One piece is bent to form a square of sides of length x centimeters. The other piece is bent to form a rectangle of length L centimeters and width 3 centimeters. The diagram below, not drawn to scale, shows the square and the rectangle. All right.
Right.
So here we have the square and the rectangle, and it is that we're going to now do some working out with it. So we've gone ahead and labeled. Awesome. And we're asked to write an expression in L and X for the length of the wire.
Yeah.
So again, we've gone ahead and written our equations. So 4x plus 2L plus 6, right?
Right. And it is talking about the length of the wire. Right? Really, what they're asking us to find, or what they are suggesting here, is that we find the perimeter of these shapes. Right? Because the length of the wire is really the perimeter, the distance
around the
boundary of each of these shapes.
All right. So they asked us again to show that L is equal to 13 subtract 2x. All right. So again, we used the information that was given, and we just simply, equated that to 32. Did our substitution, right? And we're working our way down, and simply we found out that L is equal to 13 subtract 2x.
All right. So we have proven it.
So we've simply proven that L is equal to 13 subtract 2x. So not all the time when we're looking and doing an equation, it is that we need to find a numerical value.
Definitely.
Sometimes we're doing a little bit of a proof. Guys, if they say, show me this, you're just going to show them. Don't bother say, oh gosh, I don't see, it's 2, it's 100, how I get the answer? Relax. You're just simply showing or proving your answers.
So true.
Right?
So true.
So it's important to note what the question is asking you for. All right.
All right. All right. So is there another part to this question?
All right.
All right. So here it is saying that the sum of the areas of the square and the rectangle is represented as S. All right. Now we need to show that S is equal to x squared subtract 6x plus 39. Now the sum of the areas.
So now we're looking at area. So before we looked at perimeter, now we're looking at area.
Right.
Okay. All right. So again, We've highlighted the area of each one of the shapes. And as you can see, because this one is a square, the area is x squared. And with our rectangle, the area is 3 multiplied 13 subtract 2x.
Right.
All right. So now I want for you guys to show this at home. So take a picture.
Yeah.
Take a picture. We've been working so hard this morning. We've been talking about the strategies, and we want for you guys to do this one as homework, don't it? We can give them some homework today.
Right.
So let's do some homework. Take a picture of this and show that s is equal to x squared subtract 6x plus 39.
Yeah.
No. We're out of time for this lesson. Thank you so much for joining us today. Keep practicing and stay safe.